Okay, so now I'm going to actually start by doing an example of how to create a 5-number summary and box plot. So in this data right here, the easiest two numbers to get from the 5-number summary are the minimum value, which is right here. This is our minimum, and our maximum value. Those are two of the numbers in the 5-number summary. Now I have to locate the median. That's the next step. You'll notice, however, that this data is already in order. If I did not have it in order, I would have to first place it in order. I do want to make mention of that. But here I need to locate my middle number. One way to do it is literally just go like this until you get to your middle number. The other way to think of it is there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 values. There are 13 values in our data set. If you take 13 and you divide by 2, you get 6.5. Even though that's a harder number to work with than if I had 14 values and I would get 7, it's actually easier when completing this. It means that just past 6.5, just past 6 values, you're actually going to have your median right in your data set. When you have an odd number, your median will be there. It means that I have 1, 2, 3, 4, 5, 6 values on this side and 1, 2, 3, 4, 5, 6 values on that side. If I had a separate value here like 26, I'd actually have to average, the middle two numbers. So you would go 7 in and then there would be 7 on the other side, so you'd have to average the two of them. But for this data set, 13 is our median. Now, in order to locate the next quartile 1, quartile 1 is halfway in between your median and your minimum. You actually go in 1 point because this is your median, and you start here. If I go in from here and to locate my quartile 1, I go 1, 2, 3. It's actually right in the middle of these two values. So again, you don't go from your median, you go 1 in, and it'd be 1, 2, 3, halfway in between those two values. So you would take 10 plus 11 and divide by 2, you get 10.5 would be my quartile 1. And now your quartile 3 will be halfway in between these two values. So again, you go 1 in from the median and it's halfway in between these values. 1, 2, 3. It's in the middle of these two, which happens to be 17. You can take 16 plus 18 divided by 2 and you're going to get 17. That is your quartile 3. I now have my 5-number summary. My minimum, a quarter of the way up, is my quartile 1. A quarter of the way past that is my median. A quarter of the way up beyond that, 75% point, is my Q3, and my maximum is 24. Those are my 5-number summaries. So now I want to create a box plot from that 5-number summary. Well, I will tell you that you can create a vertical axis. You don't have to. Some of the box plots you see won't even have this component to it. I'm going to create that, and I'll show you what this 5-number summary looks like in graph form. You will first start with making sure that you have all your numbers represented. So I have 8 to 24. I think what I'm going to do with my graph is go by 2s because it'll be too many values if not. So I'm going to go 8 and then 10 and then 12, 14, 16, 18, 20, 22, and last but not least, 24. These middle values will obviously be those middle values. But I'm going to leave those out so that it doesn't look too overwhelming. The way that a box plot works is I'm going to put a line for my minimum value. I put a little bigger line where my Q1 is. So my quartile 1 is at 10.5. So there, it's between 10 and 11. It's going to be right in here. I put a little bit bigger line. My median is 13. That's right here. Okay, and it's just as big. It's a big line. The quartile 3 is 17, which is going to be up here. And now I connect these 3. When I introduced box plots or the 5-number summary, I told you that the really important part of this is this middle 50% of your data. This middle 50% of your data from quartile 1 to quartile 3. So this is your 25% mark. This is your 75% mark, 75% minus 25%, you've got 50% of your data right in this middle range. That's going to be the important part that we're actually looking at. And then last but not least, my maximum is out here. I will tell you, we may be adjusting this maximum in a second and what we call the whiskers on it, but I'm going to put it here for now. That is what we call a box plot. So you have now on this box plot your minimum, your Q1, your median, your Q3, and your maximum value. That's how a box plot looks. The last step in all of this for this unit is checking to see if there are any outliers in the data. It looks like 24 might be pretty far out there. It's a little further from the data than, and it looks like my distribution looks to be skewed. It's like way on this end, there's this tail. Well, I want to check to see if there are any outliers. We do what's called the 1.5 IQR inner quartile range is what that stands for. Inner quartile range criterion. What we really do is we take the middle 50% of the data, whatever values that spans, we take that middle 50% and we multiply it by 1.5. We're gonna add whatever we get for that, we're gonna add it to Q3, and anything outside that range would be deemed an outlier. And we're gonna subtract it from Q1, and anything lower than that would be deemed an outlier. So let's do the math right now. So I'm gonna take 1.5 first and multiply times my inner quartile range. My inner quartile range is gonna be my Q3 minus my Q1. It's how many values this spans right here. So my Q3 is 17, and my Q1 is 10.5. So I'm gonna take 17 and subtract 10.5, and that is 6.5. But I have to multiply that by 1.5 to get 9.75. That is my 1.5 IQR. So what we just did right there is we did 1.5 IQR. The last step in it, now that I have that number, I'm going to take my Q1 and I am going to subtract 1.5 from Q1. Like how much further over here? So you take 1.5 IQR, so Q1 minus that. The math behind that, my Q1 is at 10.5. I'm going to take 10.5 minus my 9.75, and that gives us 0.75. There are no values lower than 0.75. In fact, our lowest value is 8. So there are no outliers on that side, But I didn't really suspect any there anyways. Let's do the other side. You're gonna take Q3 and you're gonna add 1.5 IQR, meaning I'm gonna take that 9.75, I'm gonna add it to Q3, and anything outside on that larger end would be deemed an outlier. So I'm gonna add it. So Q3, here's the math behind it. My Q3 is at 17, and I'm gonna add 9.75. And we are at 26.75. There can't be any values higher than 26.75. So if there was a 27 out here, it would be deemed an outlier, but 24 is our maximum, so there's actually no outliers on that side either. I do want to show you just briefly what we would do if 24 was an outlier. If 24 was an outlier, we would actually make it look like this, and we would erase this part of the graph right here. We would put this, that's how we deem something an outlier, and then we would go to the next lowest value in our data set, which is 18, and we would actually end our graph at 18 instead. So if 24 was an outlier, that's what the graph would end up looking like. Just in case you encounter that, I wanted you to see what it would look like. We happen to have no outliers in this data set, so we would have left it going all the way to 24. So there is your example. I'm going to stop the recording now. If you want to see how that transfers into the applet, go ahead and click the very last video of the